There are 5 general types of reactions, and by knowing these patterns in reaction, we can sometimes predict products that may form. Combination is when 2 substances combine to make one substance. Decomposition is when one substance breaks into 2 or more different substances as products. Single replacement is when there's a switching of ions, typically from one metal to another. So for instance, it was with B, now C is with A. Double replacement is when 2 ions switch. A and B are together, C and D together are as reactants. Now D went to be with A, and B went to be with C. Combustion is when a substance reacts with oxygen, typically a carbon-containing substance reacts with oxygen, and in complete combustion, carbon dioxide and water are produced. Our first examples just identifying the type of reaction. So we're going to classify the following reactions as combination, decomposition, single replacement, or double replacement. Combination, by the way, is sometimes called synthesis. So this one we have a single thing breaking into 2 different things. So if we look at our examples here, looks a lot like this pattern, decomposition. So we have the reaction here, decomposition. Now the second example, we have ions that looks like they are switching around. The phosphate was here with the potassium, and now the phosphate is over here with the copper. Now the chlorine was with the copper, and now the chlorine is over here with the potassium. So we had 2 things swap places, or in other words, we have what's called a double replacement. So we can identify that reaction as a double replacement. Now, the usefulness of knowing the types of reactions is in this next thing we're going to do. We're going to predict the products for each of the following and balance the equation. So let's say we know that the following, when they react together, will produce a single replacement reaction. And it's pretty characteristic when a metal reacts with an ionic compound like this, it's pretty characteristic that a single replacement reaction might occur. So let's look at what the products might be for this. Now, we know that single replacement involves the swapping of one thing. So C goes to be with A in this case. But the question is, which thing is going to swap? Well, is it the copper that's going to go be with the aluminum, or is it the chlorine that's going to go be with the aluminum? Well, the way to know that is to know what kind of ion each of those forms when it forms a compound. You see, aluminum is a metal right here. So aluminum, when it forms a compound, it's going to form a positive ion. Now copper also is a metal, and so when it forms an ion, copper is also going to form a positive ion. But chlorine, on the other hand, chlorine is a nonmetal, and so when chlorine forms an ion, it will form a negative ion. So we can see that the negative is going to go from being with one positive to being with the other positive ion. So let's look at the result of that. This chlorine then is going to leave the copper, and it's going to go be with the aluminum. So we'll have to figure out what that compound is when aluminum and chlorine are combined. Now aluminum characteristically charge, and chlorine characteristically forms a -1 charge. So through the crisscross method, we could figure out that the compound that forms would be Al3. And the thing that's left over is this lonely copper Cu. Now that copper is going to be a solid. It's left over, it forms a solid metal. And technically we're supposed to predict the state of matter here. Although it doesn't really factor in for our purposes too much right now, it is important for other things. Now, this is going to be a little tricky at this point because we have not learned solubility rules yet. So we don't really have the tools yet to really know how to predict. You may have to look up some information. For instance, in our textbook on page 375, we have the solubility rules given to us. This is the way to predict whether something is a solid or it's dissolved, it's aqueous. So soluble, it will be aqueous. If it's soluble, insoluble means it will form a solid. Some of these might also form gases. And so that, in that case, we might have to look up and research what that compound is at standard temperature and pressure. This particular compound here, chlorine, solubility rules, is typically soluble. So I would predict that this compound would be aqueous. Well, the next thing is we need to balance this equation. So we have aluminum, we have copper, and we have chlorine. Aluminum, copper, and chlorine. One aluminum on the left, one copper, and two chlorines. One aluminum on the right, three chlorines, and one copper. Now notice chlorine and chlorine on the left and right. We have 2 and we have 3. The least common multiple is 6. So we know we're going to need to get 6 chlorines at some point. So we could do that with a 3 here. 3 times 2 will give us 6 chlorines. And we could have a 2 right here. 2 times 3 will give us 6 chlorines. But that's also going to change the other numbers, of course, too. So we have 3 times 2 coppers. So now or 3 times 1 copper, I'm sorry. So we have 3 coppers. And we have 2 aluminums now, too. We can fix that, though, pretty easily. We can get 3 coppers by putting a 3 coefficient here. And we can get 2 aluminums by putting a 2 there. So now we have 3 coppers and we have 2 aluminums. 2, 3, 6, 2, 3, 6, and there's our balanced equation. Let's do one more example. So let's say we know that the following reaction is a combination reaction. And it's magnesium plus chlorine gas, and we need to predict what the products would be. Well, if it's combination, we have a fairly simple process of just figuring out what the result would be from the ions, magnesium ions and chlorine ions. Magnesium characteristically forms a 2+ charge. Chlorine, a -1. So we can use the crisscross method and predict that it would be MgCl2. Crisscrosses charges around. And again, it's somewhat challenging to predict whether it would be solid or aqueous, the state of matter. Based on the solubility rules, chlorine is typically soluble I'm going to predict that this is aqueous. So we check to see if it's balanced. There's one magnesium here, one there, 2 chlorines here, 2 there. And neatly enough, this equation is already balanced. So this is our answer for that problem.